Hi. Boy, that's a long first day, huh? Anyway, I will do this periodically and review what we went through in all the classes today, as you have to start to realize that there's a lot of back and forward feeding in this as we look at how emergent a lot of the software gets. All right. In the Civil Drafting 3 class this morning, it was a long day, 3 hours. We determined that probably everyone needs to check stuff and decide that something is 7 a.m. Central Standard Time and get there at that point in time. That said, it's kind of tough that first day of class. We looked at the concept of metadata and orthophotography, two very large keywords that we all should be very aware of very early. What is orthorectified photography? What is metadata? Data about data. We also looked at City of Stevens points, 3-inch orthos that are out on the web. We realized that in a class experience that when people were told to go out and get some aerial photography, they tended to go just to the easy site, which was Google Earth. They didn't even necessarily go to Bing's site, or if you would, Microsoft's site, which is the virtual Earth site. We have to realize that those who know the most about the land are probably those that get income off of it, and that would be municipalities. So City of Stevens Point has a website. Actually, the site is maintained by Rupert Milke, and it uses one of the major GIS engines in the world. So metadata, orthophotography, the fact that municipalities maintain their own GIS information. We then compared a couple and talked about some of the big players in the world. You've got Google Earth, you've got Virtual Earth, and then we don't want to forget Esri, which is ArcInfo, ArcGIS in that world. So we talked a little bit about what we had done in Civil Drafting 1, if you would, and the fact that basically that class dealt with learning how to set up projects, how to deal with points, point group manager, a little bit about feature lines, and key to the end of that class was making something called surfaces, which many of you will know as TINs, triangular irregular networks, or as digital elevation models, but making surfaces. So that's kind of the process that you went through in Civil Drafting 1. Obviously a lot more than that. The notation, the annotation stuff is huge. And we talked about the fact that we've got a very big variety set of learners in there, some that have been using civil drafting. We looked at course competencies, and you will realize in there we did not talk about software specific. That will come in the learning objectives, and realize that, however, what your employers want out of you is that you're going to design safe roads, you're going to think proactively, you're going to triangulate solutions, you're not going to just pick one. And I left a problem on the board and didn't fill it out through, so I'm going to make an apology for that. I'm going to explain first how to do it, and then I will post out in a separate program or site the math that was involved. Realize I did not put up coordinates there, so there was no numerical solution. But if you have 2 points, you know the slope of the line. If you know the slope of the line in 1 point, you can write the equation of the line. If you know the slope of the line, you know the slope of its perpendicular. It is the negative reciprocal. If you then know the slope of that negative perpendicular and a point through which it comes through, or I'm saying a negative reciprocal, you then can write the equation of the second line. You now have 2 equations, 2 unknowns. You can determine where they intercept. And that will then, you can determine from that exactly what is the station and the offset of the point that we were questioning there. Obviously, much faster, much cleaner to put the points in a drafting engine like AutoCAD and do the mathematics that way graphically. You can do it in Civil 3D. I'm sure there's a whole lot more. I'm going to let you know that we can turn on this thing and record all of class, but unless we have some people volunteering to edit it down, that's got only a certain utility. That's what we did in, we're up at 4 minutes here. I got 10 minutes out at YouTube. We went, then had a little bit of a break, talked to a few people. In the stormwater class, we went through the fact that a lot of it is going to be physics-based, even though it's not a formal prerequisite. The fact that you're going to use Microsoft Office, Excel to do work. And within stormwater, within the competencies is that you should always be looking at the catastrophic event when you're dealing with this stuff. You should also be looking at the public trust doctrine for the waters of the state when it comes to stormwater work. We'll fill in a few little holes there as we start getting going. I mentioned that out on Blackboard there's a little bit of an assignment that will work then again in class on Wednesday. You want to check back perhaps to get a little bit idea of how you're going to go about doing that. But basically we're looking at the application of problem solving and the kinematic equations, which is F equals ma. All right. In the soils class, which many of you have had and some of you are having now, we met some new students. We did a couple of math problems, believe it or not. We looked at what 6 divided by 3 means. We looked at what 79 divided by 0 means and what is the answer. We talked a little bit about the iPod Touch and access to the internet. We talked about the fact that soils are, an important part of the biosphere and a part of the world, and the fact that the concept of sustainability is no longer this foreign concept of civil engineering. We have a very interesting and good group of students. We hope that we feed back and forth information as we go, and this will be one of the conduits that you do it. We mentioned in this soils class that out at Google Books you can get a lot of good books, and one of them would be some decent geology books as you kind of learn to look and get to some wonder about how the world was created, the different theories, and how that's that rock can eventually become something that sustains life on the planet. A number of you I grabbed up on the outside and kind of hopefully rocked your world, and everyone will be on the same page with regard to that the next couple of days. One thing I will let you know that was striking to me was that, in fact, we are all busy and we can't go everywhere and look at everything, but this sense that you need to really take advantage of all the resources that are out there for your learning. There is an incredibly good set of lectures out at Berkeley and MIT and a number of other places having to do with physics. Physics is the basis of most of the engineering. The basis of physics is the math, and we see then what is the conundrum. Finally, as we fill this out, pointing to the first and second semester folk, we worked a hydrostatics problem in the soils class this morning that we called it Dubé. We had a 10-foot wall that was subject to hydrostatic pressure. That was all about the fact that you need to draft things out and give them units, and the fact that even as we go through 10 hours of math, we need to realize that a lot of these concepts are very basic, area underneath and slope thereof. We learned that the opposite of the derivative is the integral, and the opposite of the integral is the derivative. We don't even know what they mean. We already know the opposites. We learned that the opposite of addition is subtraction. The opposite of multiplication is division. We didn't go much farther. We learned that if you have an equality sign, you can do anything to either side of that equality sign except for divide by 0. So we've got great students, different learners, different types of learners. I want you all to realize that the software and the invention is coming faster than most of us can even begin to think to keep up with it. So if you've been a learner that's been having a hard time thinking of math a particular certain way, there are new ways coming. We're going to probably still want to fill out those other ways so you can get into programming computers in some way, shape, or form and be creative. YouTube gives me 10 minutes. You ought to give them a call so they'll cut me off. Thanks for listening. See you tomorrow.